All right, welcome back. This is part 2 of 3 for lesson 1. We want to look in this video at what does an exponential function look like, which means we're going to look at their graphs. So what we're going to do is simply just plug in some values into the function, figure out their coordinates, and plot those coordinates on a set of axes. It's very simple. So let's look first at y equals 3 times 2 to the power of x. You'll remember this from the first video. This was our first example. This is a growth model, which we recall says as x gets bigger, y gets bigger, or as x increases, y increases. So let's think about what this is going to look like. If we looked at x and y values, and I want to look at the values -2, -1, 0, 1, and 2. Now, we should recall from the last video, we should know what the y-intercept is when x is 0. That's our initial condition, but we can verify. 3 times 2 to the power of 0. So 2 to the power of 0 is 1 times 3 is 3. When we plug in -2, we have to remember our... Actually, let's look at the positive values first. If we plug in 1, we get 3. I'm going to do some scratch work down here. 3 times 2 to the power of 1. Well, that is 3 times 2, so that's just 6. And then when I plug in 2, I get 3 times 2 to the power of 2. Well, 2 to the power of 2 is 4, so we get 3 times 4, so I get the value of 12. Going in the opposite direction, when we plug in -1, we have to recall our study of exponents that says if I take a negative exponent, that means I flip that number over, or I find its reciprocal, and change it to a positive exponent, so 2 to the first. Well, 3 times 1/2 is 3 halves, which is 1.5 for those of you who don't like fractions. And the last one, same idea. We have to take -2, which means we have to flip it over, or find the reciprocal, and change it to a positive exponent, which gets 3 times 1/4, which is 3/4, which is 0.75, again, for those of you who don't like decimals. So we went to x equals 1 and 2, -1 and -2. And here is where things get a little tricky. Obviously, you notice we have everything from less than 1 all the way up to 12. So we're going to do our best to go, let's go probably 2, 4, 6, 8, 10, 12 to hopefully hit as much as we possibly can for this graph. All right, let's plot our points now, as we always do. Let's go to 2, 12. Go to 1, 6, 0, 3. All right, now we have to do some guessing here because we don't have all of those points. I'm going to put the halfways in here, which are the odd numbers. So it's 2, 4, there's 6 right there. Well, we have -1, comma 1.5. So there's 1.5. We have -2 and 0.75, which is not quite to 1, but not quite to half. And there we have 5 dots. Now here's some things that we have to understand. As x gets bigger, or as x increases in this direction to the right, y is always getting bigger, and it gets big very, very fast if you were to start plugging in points. So what this does is this comes to the right, and it just keeps getting steeper and steeper and steeper. It doesn't quite go vertical ever, but it does get very, very steep. Now, in the opposite direction, in the negative direction, as x gets more and more negative, these y values will never become negative. So what it does is works like an asymptote. There's actually an asymptote here on the x-axis for our exponential functions. So we come down here and it just gets really, really close to the x-axis but never crosses the x-axis. So this, as we know, is a growth model. As x increases from left to right, y increases as well. So this is an exponential growth function. This is how we're going to graph these functions. We are going to look at plugging in x values or substituting x values and getting the corresponding y values in order to graph. All right, that example out of the way, let's take a look at another one. This one, again, is from the last video as well. And in this particular case, we have the decay model of y equals 1/2 to the power of x. We're going to do the same idea. We're going to do the same idea. We're going to get a table of values so we can plug numbers in. So we get -2, -1, 0, 1, and 2. All right, when we plug in the value of 0, 1/2 to the power of 0 is 1. And since our initial value is also 1, that makes sense. 1/2, we're going to do the scratch breakdown here again. 1/2 to the power of 1, well, that's just 1/2 because that's what the exponent of 1 means. When we get 1/2 to the power of 2, it squares both the top and the bottom of the fraction, the numerator and denominator. So we get 1/4. Notice if we continued this, we would get just 1/8, 1/16, 1/32, and those numbers just keep getting smaller and smaller. All right, when we take 1/2 to the power of -1, remember the negative exponent tells you to take the reciprocal. So the reciprocal of 1/2 is 2 to the positive exponent of 1. So that means our answer here is 2. Likewise, doing our last little piece of scratch work, we get 1/2 to the -2, which means we take the reciprocal and change the exponent to a positive number, which 2 to the second is 4. So let's take a look at what that looks like graphically. You might guess what it's going to look like, I would hope. In this case, we only have to go up to 4, so we think we've got plenty of room there. 2, 3, and 4. All right, we're going to switch colors, and we're going to graph these coordinates. So we have the point 0, 1, 1,2, and 2,1/4. And in the other direction, we go up to a 2 at -1 and up to a 4 at -2. Now, this graph has the same idea, just goes in the opposite direction. So on the left-hand side, it's very, very steep. And we'll do as best as I can here to get this to go to a smooth curve, which I do not do very good job on this. But it's okay, because we have the basic shape of a decay model. This is a decaying graph. As x increases, y decreases. And you'll notice that these are not linear, obviously, and it's not quadratic or cubic. It has its own shape. All right. This example will be a growth. But what I want to do is I want you guys to graph this one on your own, see if you can plot the coordinates. And I'm going to leave us at that for this particular video. And remember to continue on to part 3, where we're going to write some equations from some given information of an exponential function. All right, I'll see you guys later.